Okay, so this is going to be a joint talk of me and Raquel, but these are only my slides. I said I'm going to talk about 3 things, but I'm only going to talk about 2 things. So the first and the last. So games and language structure and games and language use, basically. And that's, well, there are 2 PhD students there, and one is going to talk about language structure, more or less, right? And the other is going to talk about language use. And I would say that game theory is useful for both. I'm not sure whether actually they're going to use both game theory, but let's see. So first, meaning and meaning structure. Conventional meaning and the meaning of predicates. So if you do model theoretic semantics, then you model the meaning of a predicate just by a set of entities, just by a set of objects, right? But that's, of course, in a sense, completely crazy, because then you have much too many meanings, too many possible meanings, right? And if all possible set of individuals would be a potential meaning of a predicate, a potentially good meaning of a predicate, then basically you can never learn your language. You can never learn meanings. And then you can never learn, induction would be impossible. And actually it has been pointed out by various philosophers that, well, we need the distinction between, let's say, properties, natural properties that predicates, so predicates that occur in language can actually mean, versus, well, just all possible meanings as possible sets of individuals. To account, for instance, for natural laws, for meaning, and for rules, giving all these deep philosophical problems by Kripke, Putnam, and Goodman, and so on. Okay, now what some philosophers then have said, Bas van Fraassen, for instance, a Dutchman, and Bob Stalnaker said, hey, what we need to do is to have structure. We need to have more structure in the meaning part. So we need not just a set of individuals, but those set of objects, or so they have to be structured somehow. And then this structure can be used to distinguish natural meanings from non-natural meanings. And Gordon Force has said that he uses these type of structural meaning spaces and to model then meanings as convex sets. But it doesn't say really why these convex sets are good, or at least he says, yeah, they're good because they're easy to remember and maybe easy to learn. But actually, what we want to say is that we want to give an additional motivation for why we have natural properties. This is actually old work, but still. And what we're going to use is game theory, in particular Lewisian signaling games, because the idea is, well, hey, language use, that's interactive. We need a theory of interactive, let's say, decision making, and that is game theory. And signaling games are particularly used or devised by David Lewis to account for, well, communication. Signaling games consist of 2 agents, namely a sender and a receiver, or basically agents that are both have a sender role and a receiver role. And what I'm particularly interested in is, so David Lewis came up with signaling games to account for conventional meaning, but he uses actually a rational game theory, so he assumed that people are completely rational, but that's actually already, well, so he assumes that people have complete common knowledge and they are completely rational, but that's actually asking much too much to explain meaning or to explain good communication, because what we see in the actual world is that not only humans who are not even perfectly rational and have complete common knowledge, but also lots of animals, they have communication systems, and we want to account for that as well. So, and they also have a conventional communication system, we want to account for that as well. So it's better to have, to build your game theory on less ideal circumstances, and one way to go is to use, well, evolutionary game theory, where you basically assume that the agents are pretty dumb, or reinforcement learning, where you basically assume very same thing. Okay, so here's the kind of game that we use, the signaling game. That's also used by David Lewis. It's a sequential game, so it says, well, nature chooses first, but what you assume is that, well, you have a set of states, or set of states T, and then one of those states is actually a true state. Yeah? And then the sender, he knows what is the true state. The receiver, he doesn't know what is the true state, but the receiver has to do an action, a certain action. And this action, let's say, is either good for both or bad for both. Yeah? Now, So the receiver has to do the action, the sender sees the actual state, well, but then the sender can actually state a message, right? And then he can say in which state he is, and then the receiver can do the action. That's good for both. Unfortunately, the sender can only state a message, but the message doesn't have any meaning yet. It just means boo or ba or whatever, right? So it doesn't mean anything. And now the idea is that, well, through playing the game, so you get an equilibria of this game, and the equilibria of the game, they determine what are the meanings of the messages. Let's see. So here's a very simple example. Suppose you have a game with only two types of situations, two dots. And then you can also, the sender, he can send either one of two messages, let's say boo or ba, they don't mean anything. And then the receiver, he can do two actions. One is good in the first state, and the other is good in the second state. And that's what the utility matrix is saying, right? So if the receiver performs A1 in state T1, it's good. If he does A2 and T1, it's bad, and the other way around. Okay, so now, so in each state, the sender has to say the message, and then you see what is the equilibrium of the game. So it's an equilibrium concept of game theory. And what you get out of this, if you implement this, is just as you would expect, right? So this is, for instance, an equilibrium in the first state. You say the first message, and the first message is on top. So in the first, if the hearer receives the first message, he does the first action, and the second state, second message, second action. And thus, what you get here is that the message now actually gets a meaning. This is one equilibrium, namely the first message, it just means the first state. That's the descriptive meaning. Or it means, oh, do perform that action. Do perform that action. You might call that the imperative meaning, right? Of course, the messages are just boo or ba, so they don't have any a priori meaning. So it's completely arbitrary which message the speaker actually used, right? So this would be an equally good equilibrium, yeah? And just the case that the messages now have the opposite meaning. Actually, if you look at it, if you look at the standard definition of a Nash equilibrium, you see that this is an equilibrium, this is an equilibrium, but you actually get two more equilibria here. But these ones are the only ones that are reasonable equilibria, which means that they are the only ones that are actually evolutionary stable, and they are Pareto optimal, so they are the best equilibria in a sense. And like I said, right, suppose that you have an equilibrium, so speaker strategy, what is the speaker saying in each of the messages, and a receiver strategy, what is the receiver performing after hearing a certain action. If you have then a good speaker strategy, hearer or receiver strategy combination, that's an equilibrium, and you can determine descriptive meaning and imperative meaning from that. So descriptive meaning is the set of states in which the message is sent in equilibrium. The imperative meaning is the set of actions or the action that the receiver is going to do if he hears that particular message. Okay, that's very simple. Now let's go for a more interesting case. Before you had just two actions, or two states, two messages, two actions. Now we're going to have a more interesting case. Let's say we have infinitely many states. So let's say a whole line of possible states. Then we have only finitely many messages. Let's say 3. And let's call these messages colors. What do I care, right? Black, green, and red. And you have the actions. We have, again, infinitely many actions. And now what a game always has is you have a probability on the states, and you have a utility function. So what is the utility of doing a certain action in a certain state? Now, the type of situations will now be the same as the type of action. So what the speaker, he has to say in each situation, so he is somewhere on the line, he has to say either black, green, or red, right? And the hearer or the receiver, he has to say, he has to choose one of the points on the line again. And the utility will be, well, how similar, stick here, but let's say the receiver is at that point, right? And if the speaker and the hearer, the speaker and the receiver are at that point, he uses a certain message, and the action that the So then you can perform the game. You can say you can start out with everybody has a lot of agents, infinitely many agents. I don't care. They have a certain speaker strategy. They have a certain receiver strategy, and they do this action, and then in a evolutionary setting, right? The agent gets more children if he has a higher utility. Yeah. So they play the game. If you have a higher utility after playing the game, you get more children. If you have lower utility, you get less children. And then you can see what will come out at the end of the game. And what you see, okay, this is the utility. It doesn't matter, similarity. So utility is just defined in terms of similarity. And what you see is this kind of end result. So this means that, well, so before, so what would be a possible speaker strategy is that, for instance, if, well, let's say here are types here as well, that you could be that if you would be here, and you would say green. If you would be here, you would be black. You would say black. And if you were here, you would say red, or something like that. That could be a beginning strategy, but in the end, there's only these kind of strategies that could result. The first, suppose that all points on the line are equally likely. Then what you see is that, well, the first third, let's say, they all say one particular color. In the middle third, they say another particular color, and in the last third, they say another particular color. So this means what you end up with is that, with respect to descriptive meanings at least, black means, well, so what you get is a partition of the meaning space. So the descriptive meaning of black would be, or of the different colors, would be a partition of the meaning space. But what is interesting is that this partition will be into convex sets, right? So, and convex sets means, well, if this point, so I should go on top, but that's not possible for me. If this point is on the meaning of red, and the descriptive meaning of red, and this one is on the descriptive meaning of red, then anything in between is in the descriptive meaning of red. And that's what you see. Okay, so that's about the descriptive meaning. It goes, so you get into sets of convex sets, so you get a set of convex sets. The other interesting thing here is that, so that you get also a notion of a prototype, because descriptive meaning says what would a sender say in a particular state, but also we also get that the receiver has to do a particular action if he hears, for instance, red or if he hears green. Right? Now what he's going to do, given the utility function, at least at the end, is that, well, always if the receiver in the equilibrium state of the game, if he hears red, he goes to the middle of the red descriptive meaning. And always if he hears green, he goes to the middle of the green area. And the same for black. So what this gives you is some kind of so the imperative meaning of black would now be, let's say, the prototype of black. So what you have here, so you start up with a game with a similarity measure, and what you get out of is, well, actually a Voronoi tessellation where you have descriptive meaning or convex sets and a prototype. Right? So this is just one thing that you can do with this, and if you, so here we started with, okay, you can only use 3 different color words. If you get 2, right, so when you have a different meaning space, for instance, a color, then you get a different, then you have the color circle divided in 2. If you have 4, then you divide it in 4, and so on and so on. But always you get descriptive meanings, partitions the meaning space into convex sets, and you get also a prototype. Okay, it's very interesting. But of course, right, this is just the beginning, and what can you do more with it? Well, one thing that we did more with it is to say, okay, so in this, what we have here is that the meanings are always very, so they have very clear boundaries, right? For instance, blue here, clear boundary between what is blue and what is white. But we don't see that in actual language. How can we get vagueness out of that? Well, we try to account for that. Here we have only one kind of word, namely color words. What if we want to have different types of words as well, right? So we have adjectives, we have nouns, we have all types of different things. How can we can account for these things? How can we account for ambiguity instead of vagueness, right? There is a difference between vagueness, generality, and ambiguity. How can we account for ambiguity? And, okay, so these are all things that can be done. One of the things that can be done, actually, is to play with the notion of similarity here, right? So, in this, what you do in this model is that you just have a set of points, right? And you have a similarity between points by just how close the points are to each other. Right? But there are many ways of measuring similarity. For instance, we could say, no, what the meaning space consists of is a set of objects, but these objects are just defined in terms of sets of features somehow, right? And then you define the similarity between two objects in terms of, well, either how many features they share, or how many features they don't share, or the set of features are actually more structured, right? And then you can more naturally account for the meaning of common nouns, for instance. Okay, so that's one thing that I've been doing, and I hope that Thomas especially will continue working on this. Okay, then I wanted to talk about the logical vagueness, but let's not do that. I will go to actually something that Julian should work on, and that's not so much about language structure, but more about language use. And so language use, so that's more pragmatics, right? I worked a lot on pragmatics and also used game theory to account for that. Now, standard pragmatics is of course very well studied, but it's also very limited if you look at it, because if you look at the standard literature in pragmatics, they all assume that participants of a dialogue are actually very cooperative with each other, right? Now, that's maybe between the two of you, right? But trust me, it's not always the case, right? So normally if you have a dialogue, you also have divergent interests. Now, divergent interests, right, it's almost assumed in Gricean pragmatics that does not exist. People are always cooperative with each other. So how can we extend pragmatics, the ideas of pragmatics, if we don't assume cooperativity? That's the question. Now, and I think that game theory is actually an ideal tool to study this, because game theory is about interaction. It can account for communication, but it doesn't assume that, or it doesn't have to assume that the preferences are completely aligned. Now, so here's one way that I would like to think of as persuasion, right? So what's the idea of communication? Well, I don't know about you guys, but my idea to communicate is, I want you to do something that is good for me, right? So, and here's an ideal way. So you face a decision problem, you don't know what to do, right? So your decision problem is, oh, I don't know what the state is, but I have a probability over the state. So the state is the set of S, the set of possible states. You have a probability over those states, and you have a certain set of actions that you're considering what to do, and you have a utility function. So given that state, how good is that action? Yeah. Now, suppose now that I actually know better than you do what the actual state is, right? And I have a preference, so you are going to do the action, right? But I have a preference over what action you are going to do. Then the idea of persuasion is that I'm going to make you do the action that I prefer. And whether you agree with that's a good action, I don't care, right? So the idea is that communication is good for, I want you to do something that's good for me. Okay, so this involves, of course, the actions of speaker and hearer. So game theory is natural for that. Now, standard, at least in signaling games, right? So again, we're using signaling games here. It's assumed that if I use a certain message, suppose that it already has a certain conventional meaning, then whether the conventional meaning that I use is actually, it's standardly assumed it's not verifiable. So I can actually just say, oh, this room is red, right? Whenever the room, although the room is actually not red. That's possible. So standardly it's assumed that there is no incentive to speak the truth. But let's assume that for some reason, right, you do have an incentive to at least speak the truth. So if there is no incentive to speak the truth, right, then of course I can mislead you then I can try to mislead you. But suppose that there is actually an incentive to use it's guaranteed I can only say something that's actually true. Still, even then, misleading is still possible. Right? And that's actually why the courtroom, they say, oh, you have to speak the truth, but not only just the truth, but you have to say the whole truth. Right? Look at this particular decision theoretic situation. Suppose right, you're considered for this decision problem. So you consider three possible situations, T1, T2, T3. Oh, I don't speak the microphone, anyway. And you considering which action should I do, A1 or A2. And suppose that all situations are equally likely. Now, what are you going to do? Well, the action that is the highest expected utility, and that's going to be action A2. You see, because that's expected utility 0, while the expected utility A1 is the lower utility. Yeah? Now, suppose now that I know actually that action. Suppose now that the actual world or the actual situation is T1. Yeah? Is T1. So that is, right, so T1 is actually the situation that, A1 is actually the situation that you should do because that has the best thing. But now suppose that I say, right, something that's true, but still something that makes you change your action. For instance, I say T1 or T2 is true, right? That's a possible meaning. Then you will change your action. Although, because then A1 has the highest expected utility. You see that? So although I say something that's true, I can mislead you because, well, you would have done the right action. I say something that's true, and now you're actually going to do the action that's worse for you. Yeah? Okay. So, and now suppose that, we actually have a situation that's for me, that although for you it would be better to do A2 in situation T1. For me it would actually be better to do A1, that you do A1 if you're in situation T1. Yeah? Then, for me it would be very natural to use, to say, oh, we are in T1 or T2. Okay. So then, persuasion makes a lot of sense. Unfortunately, here's the problem, right? If you use standard game theory. If it's common knowledge what the hero decision problem is, and it's clear what the speaker's preferences are, and both people are perfectly rational, then you can show, right, it's a theorem, you can that actually persuasion never makes sense if the preferences are not aligned. So we want to account for persuasion for a lot of communication, right? So communication where the preferences are not aligned. But if you use standard game theory, we cannot, because persuasion always sees through why you say something different from what you. I always see through the reason why you try to persuade me. So then, in a sense, the challenge is how can we make sense of persuasion, or even of communication in general. So here's, for instance, a particular example. So for instance, we have a different decision, well, a game theoretic problem. So we have three situations and three actions. And suppose that I see the situation, right? So the first, so we have everywhere two payoffs. The first one here is my payoff, and the second one is your payoff. And for me, it's always best in this particular situation if you do A3. It's better for A3. It's better for me that you do A3 above A2 above A1. For you, however, it's always better in situation T1 to do A1, in situation T2 to do A2, and in situation 3 to do A3. Yeah. Now, suppose that I see that T2 is the actual situation, and you don't know, and I have to say something that's true. So what am I going to communicate? Well, I would like you to do action A3. So I have to say something that's true. So in a sense, my best move would be to say, well, not exactly that T2 is true, because then I'm sure that you would do action A2, but I hope you actually would do A3. So maybe I can say, oh, T2 or T3 is going to be the actual state. Yeah. Unfortunately, right? You have you can actually account for this very easily. You can see through why I say T2 or T3 and not just T2, and then argue that the speaker who says T2 or T3 must actually be in state T2, right? So the hearer can see through the reason why you say, why you are vague about the actual state. So the speaker see through, and you try to persuade somebody, somebody to do something that he doesn't really want, but you cannot actually do that. Okay, so the challenge is how to account for persuasion after all. And what you have to do is, well, maybe you have to agree, hey, preferences are more aligned than we actually think they are, so maybe it is true. Gaussian pragmatics is actually true, right? We only communicate if the preferences are aligned. More naturally is that we have less common knowledge than is usually assumed, but actually more natural is, and that's what Alex Rascaritas was asking earlier on, maybe people are actually not perfectly rational, which is now very much assumed in behavioral economics, and then because people are not so rational, more communication makes actually sense than the ideal analysis actually predicts. Well, that's one of the things that at least I also want to investigate. Now I give the word to Raquel.
Okay, so this is going to be quite different, so please save your questions for Robert. For later. Okay, yeah, so this is going to be quite different, and I guess maybe we'll also give you the chance to see how interdisciplinary our institute is, right? Because we really do many things, so you will see. I'll try to be brief in the interest of our lunch. So the goal of this part of the talk is just to give you a little glimpse, just to give you a little idea of some interesting phenomena that are related to coordination in actual human-human dialogue, right? Yeah, so I consider my research to be part of what can be called dialogue modeling. Dialogue modeling can be many things, but you can also understand it as the empirical study of human conversation, human dialogue, using the toolbox of computational linguistics, right? So I'm interested in maybe something that has been said here before, maybe in the sort of bottom-up approach, right? So I like to look at the data, at the actual language used, and then see how much insight we can get from the actual natural language in which the interactions are taking place by using natural language processing techniques. And so I would like to mention briefly 3 aspects that are connected to coordination that I see as being linked to the themes of the Essence project. Yeah, you will see what they are about in a second. So, but let me just first start by showing you a little transcript of actual dialogue, right? So that you can see how a little conversation might look like. This is a conversation between 2 people that are talking on the phone. They are just talking about random stuff. They are not trying to solve any task or anything like that. They are just chatting. And B is saying, yes, it's fun getting together with immediate family. A lot of my cousins are real close, and we always get together during holidays and weddings and stuff like that. And then A comes in. Those are the ones that are in Texas? No, here the hashes mean that this stuff is being uttered in overlap, right? So he says no, and A already goes on saying, or you go to Indiana on that. Yeah, the ones in Indiana, okay. We're in Indiana, Lafayette. Lafayette, I don't know where that is. I used to live in Indianapolis. Yeah, it's a little north of Indianapolis, about an hour, right? They are just chatting. So initially, this looks perhaps rather messy. It is a bit messy, maybe, when you look at it in this written form. If you were to listen to it, it would be very normal for us, of course. But it looks a bit messy, but actually, it's not so messy, right? You can see here that the speakers are just using different mechanisms to make sure that they are keeping the conversation on track, that they know what they are talking about, that they are understanding each other, right? So, cannot quite point here, but so you can see that A was not quite understanding. There were some issues here, so he decided to ask a clarification question about what kind of cousins B was talking about. Are those the one in Texas? Then this gets clarified, and he marks with an acknowledgement that he has understood now and the conversation is well on track. If there are other little aspects that are unclear. So again, this is clarification is asked for. And again, when things go well, this is also signaled that things go well. Yeah. So this is more or less how informal, in this case, non-task-oriented conversation looks like very often. So people have been trying to model these things, of course, and a classic model that has been put forward, in fact, within cognitive psychology, but that has been adopted and has been very influential in dialogue modeling in general, is the so-called collaborative model by Herb Clark and colleagues. And the idea here, a little bit in contrast to the more classic speech act theory that has come up before, is to see conversation not so much as a sequence of actions where the speakers have some beliefs, also some commitments, but actually as a type of joint action where we have actions by the two participants or multiple participants, right? Where the participants are constantly engaged in a process where they try to make sure that they are aligned, right? So besides the topic they are dealing with, there is this kind of extra effort on trying to make sure that everything, that understanding is taking place, regardless of what is the topic of conversation. And in this process, both interlocutors have shared responsibilities. So Clark in particular, well, together with others, I don't want to give details on this, proposes that there are at least 4 levels at which the interlocutors need to align themselves, right? The 4 levels in which actions are taking place constantly from the two interlocutors. The first level is just the level of contact. A and B need to pay attention to each other, so the channel has to be open, they have to pay attention. Then we have the level of perception in which not only attention has to be there, but we should be able to perceive what the other one is telling us. This is very basic. Then we have a level of understanding where we need to make sure that we, for instance, know the meaning of the words that are being used here, or that we are able to resolve what the pronoun is referring to, these kind of things. And then the final level would be the level of uptake, where we sort of understand what's the intention behind what is being said. So, and we are able then to make a decision as to whether we go on with what is expected or not. So this is like a ladder of different actions. And what's important here is that the two interlocutors are always engaged in these two actions. So it's not a one-sided thing, but a collaborative thing, right? And what may happen is that lack of understanding may occur at any of these levels of action. So something may break down, communication may break down at any of these levels of action. And this is going to trigger different types of reactions, right? So this is going to be signaled in different ways depending on at which level the problems occur. And by looking at conversations, you can see how people try to repair at different levels if problems occur. And the goal is to achieve sufficient understanding at all of these levels. What is sufficient understanding is going to depend on the particular task at hand, or what is important for that conversation at hand. But what matters is that this level of sufficiency takes place at all these levels. Yeah, so this is a bit the general model put forward by Clark and colleagues. And now one domain where these things have been studied in particular, a paradigmatic case study, is the domain of referential tasks. So there are many experiments that deal with this paradigm. So you can imagine two people that are being asked to play a game where they are being showed cards like this shoe here, and then they have to refer to these cards, and the other interlocutor has to be able to identify which card you mean and put them somewhere or something, right? So it's a referential task. You try to be able to refer to one of these cards, the other one has to identify which card you mean. And then you end up with conversations like this one here. So A is trying to refer to this car, and he or she proposes a particular description, a particular concept that may refer to this object, like a dog cider. This initially does not work, right? So that's not something that B can use to actually establish a reference. So she clarifies a word. Is that a kind of dog? No, it's a kind of a leather shoe. It's a kind of penny loafer. Okay, then this seems to work better. This new sign, this penny loafer, seems to work better. So A confirms, okay, I got it, fine, right? So now with this little conversation, they have found a sign that works for the two of them at this point to be able to identify this object. So they have find this. Now they are going to stick to this particular concept, so they have sort of established a particular, like an ad hoc convention that works for the time frame of this conversation. And sorry, this is more what I was saying what's at the end is what I was saying now. But what's important about this little exchange is that in this referring task is not that the speaker only has one opportunity to put forward a sign and that this is going to succeed or to fail. We have a cooperative project here, a coordination project in which speakers can reformulate if that needs to be the case, and in which the addressees can give feedback and sort of contribute to find what's the sign that works for them in this particular situation, right? So it's not a one-shot thing. And as I was saying before, once they have found something that works for them in this particular situation, they create what has been called a conceptual pact, which is just a particular conceptualization that is fine for this dyad, right? For this particular pair of interlocutors for the time frame of the conversation. A little convention, a temporary convention, if you wish. Okay, so this kind of collaboration, of coordination that I've been mentioning up to now is a coordination where if you analyze conversations, you see that that is quite explicit, right? You see this by how the speakers ask clarification questions or how they explicitly acknowledge that something works, right? So we can call it explicit coordination, something that is very visible in conversations and that has inspired also research on how to implement artificial conversational agents, how to develop automatic models of dialogue, and so on. Now I would like to mention another type of coordination. And sorry, maybe it wasn't clear. I've called it micro-coordination because this really takes place at the micro level, in the sense of at the turn-by-turn level. You can really see it at the microstructure of the conversation, just to make the clarification. All right, now there is another type of coordination that is also very visible when you examine data of conversations. And this is a coordination that has more to do with structural properties. So I'm using the term convergence here, but I don't mean concept convergence like it has come up before, but something that is more structural. So by the way, let me just say an aside thing that I think that we really in this room, we are prototype case study of people trying to, using very similar words that overlap a little bit, but we don't quite know exactly. We don't quite know exactly whether we use them in the same sense or not, and it's going to take us a bit of effort to figure out whether we mean the same thing. Anyway. Okay. Okay, so there will be a lot of data to analyze, clearly. Okay, anyway, convergence. In this case, I mean convergence at a very external level, right? So it has been observed that humans, when they interact with each other, they just tend to match each other at many levels, right? And this means, I'm not talking about concepts here, I'm talking about something external. So for instance, if you're talking with someone that uses some particular syntactic structures, you will tend to use those syntactic structures. Or if that person is making some particular gestures, you will tend to adopt a bit those gestures, or you will adopt the accent of that person, for instance, right? Or even the facial expressions may have an influence on how to react, right? So there is this tendency to match at this sort of external level. I'm calling it here structural for lack of a better name. And in the psychological literature, it has received several names like convergence or alignment or accommodation, tuning, adaptation, all sorts of things. And it's a fact in the sense that when you see the data, you can quantify this, right? So you can analyze your data, you can quantify, you can verify that it's indeed there, that there is more convergence that you would expect by chance, for instance. But what's maybe not so clear is exactly what's the role of this kind of convergence. Okay, it's there, and is it helping us in any way? What's the effect? What's going on with this? So here are a few things that are known, right? So, well, no, not that are hypotheses, let's say. So one possibility is that from the human point of view, that this kind of matching is helping us to process language better. It may be that this kind of relieves a bit the cognitive load of coming up with new things. We just copy what we see, and this kind of lowers our cognitive load. But for instance, there are theories like the one put forward by Pickering and Garrett, where they claim that this kind of structural convergence at the external level actually has a causal role in conceptual convergence, so that it is this structural convergence that in the end allows you to have alignment at the conceptual level. Exactly how that happens, I'm not sure. But I mean, their model postulates that this is the case, that it is by aligning at different levels that then the semantic level also becomes aligned. Other things that we know, so that for instance, this kind of external convergence is stronger if we are engaged in a task that we are trying to achieve collaboratively. So there is some evidence showing that if the more structural alignment we have, the more task success that we achieve, although there are also contrasting evidence, so this is not very clear, but we have some idea of this. And then we also see other things, like for instance, different correlations that we can establish with the level of a structural convergence, right? So that, for instance, there is more convergence if there is more liking between the interlocutors. If you dislike someone for some reason, you could try to mark it, but actually not aligning so much. So if you may just refuse to adopt someone's accent, or I don't know. And other more social-oriented aspects, so that also we can, that the degree of structural alignment that we see also may reflect the relative social power of the speakers in a conversation, right? So, for instance, you have here some references where it has been shown that in a conversation where one speaker has less power than the other speaker, this speaker will show more alignment towards the speaker that is more powerful. And something really structural, so for instance, just we'll use more similar function words, and function words are things like quantifiers, prepositions, determinants. So something that is not about the content, it's about the style, right? So this will be reflected in this kind of power relationships. So these are things that we know, but still, so okay, looking at alignment, analyzing data in terms of quantifying alignment can be a rich source of information about the interlocutors, but it's not very clear whether this kind of alignment is really an effect of having achieved good communication and conceptual alignment, or is actually causing that this conceptual alignment will take place. So I just leave it there as something that may be worth exploring. Okay, when you want to stop me, just let me know. I'll try to go on. Okay, something else. So now, some of these models of micro-coordination, right? The one that is more explicit that I mentioned at the beginning, and also the more implicit structural one, some of them will predict stability, in the sense that once the speakers, once the interlocutors have reached, for instance, a sign that works for them, like the penny loafer, in principle that should stay the same. It works, it has led to successful communication, it will stay the same for the frame of the conversation at least. Or with the structural alignment, we predict that people will just tend to align, to converge in their external representations, and once they have converged, that will be stable, right? Possibly. However, when we look at data, actually, we can see that there is room for dynamics, that there is also change, even when successful communication has been achieved between the interlocutors. So this is another task that has been performed with humans as well, where people have to guide themselves through this kind of maze. And one of the issues that has been studied here is the type of conceptualizations of semantic frames that they use to talk about this maze, right? So they can use something that is more figurative, like the piece of the maze is sticking out, so they are referring to locations in the maze, to something that is very abstract, just talking as a matrix, like this 6-1, referring to columns and rows. So this sequence of this sequence of referring expressions here show you the typical pattern of semantic shifts that takes place as the speakers play more and more this game, right? So they start with something quite figurative, and as they play and become successful, they adopt all the types of conceptualizations of the maze until they arrive at something that is much more abstract, right? But this, so yeah, so they have been understanding each other at each of these levels, but still the way of conceptualizing the maze has been evolving during the conversation. It has not kept stable once they have reached something that works. It still has evolved to something that is more abstract. And then we can see also here on the right that if some particular conceptualization is being proposed and does not work, this often may trigger a change towards something that would be simpler in this kind of hierarchy, right? So this would be reverting to something that is more figurative after having proposed something that is a bit more abstract. So anyway, this is just to point out that there is this tendency to arrive at conventions that work for the frame of a conversation, but even when these conventions have worked, they still may evolve during the time frame of the conversation. Okay, so this type of micro-coordination really takes place at the micro level. So we are just talking about one dialogue. It's not evolutionary in that sense, right? So it's really the time frame of a conversation, very local. So one issue that, that we may wonder is what is the link between this coordination at the micro level and issues that may lead to changes in the resources of the agent at a longer term level, right? So something that we could call learning, right? So at what point, if anything, we may see changes that are more permanent in the resources of the speakers, and how this is linked to this micro level. So there are some psychological evidence that, for instance, links priming, so very structural type of convergence with implicit learning, and there are other things as well. But I think that this is also an open question. So I just wanted to mention something in connection to this that we are working on. So one aspect where it's interesting to look at these things is one context in which it's interesting is the context of language acquisition, right? Where we are talking about children that are learning language. So there are rich resources of dialogues between children and adults, children that are learning language, that they are in the process of acquiring language. And so what we are trying to do in this work is to analyze how the level of micro-adaptation may have an impact on how the child learns over time. So this is very much work in progress. At the moment, we are just able to quantify the level of alignment in different ways, and we are now trying to see how this is related to learning. So this is, again, by analyzing the data, by using different types of natural language processing techniques and trying to get at conclusions about how this is connected to learning. You can ask me later because I know you have not understood anything. Now, the last thing, just again to throw it at you and then you can ask me later. A last question connected to all this, hopefully, is that, okay, in this case, I've been talking about conversations with two individuals, right? But obviously, agents are going to interact with many more individuals, especially if we are talking now at a more longer term, we are taking a more longer term perspective, right? So it's very likely, given that agents don't have the same resources, may not have the same types of conceptualizations, that the input that a particular agent receives from a diversity of agents is going to be often conflicting, right? Not all the agents are going to agree, so there will be different types of information that will have to be integrated in some way. Yeah, so one question that we may ask is whether we are going to give the same weight to the input that comes from different agents, or whether we want to make some distinctions here. How are we going to learn from this diverse input? There are many ways in which one could explore these issues. At this point, we have been developing a framework where we use crowdsourcing data, so we gather judgments, in this case linguistic judgments, but this is not at all limited to linguistics. It could also be applied to images or other things, in which we are gathering judgments from the crowd, from different agents, and then we use ideas from social choice to try to devise methods for combining this diversity of judgments that may not be in agreement, most often are not, into something that can be think of as a collective judgment. And yeah, so I see all this as related to learning. We have these papers, in fact, don't take that perspective, but I do think that is a bit related to some aspects that have to do with the themes of essence. you can prove me wrong, maybe. Okay, I'm finished. So, just to summarize and wrap up. So, I hope that at least you've got an idea of some possible phenomena that are interesting when you look at human-human dialogue in connection to coordination. So, micro-coordination really at the level of one conversation, just turn by turn, that can be either more explicit or more at the level of structure, at the external level. Questions of how this micro-coordination may lead to changes that are more permanent, and yeah, how this can be put together with information that comes from a variety of agents. And yeah, as I said, the type of methodology that I in general I think is worth using is to start by empirical exploration of the data and using computational processing of that data to try to get insights about this. Thanks for your attention.
So, unless people are starving, I would suggest we give some time for questions, and then we leave time to lunch until 4:00. So we can make up some of the time. Plus, the afternoon's presentations, I think, are quite a bit shorter. So we'll make up.
If I can put the two presentations.
It's a question for Robert. Would it be fair to say that you're assuming a fairly strong version of the Sapir-Whorf hypothesis, that the number of message types determines the discrimination you have about categories in the world? Because it seems as though that is the thing that determines how fine-grained your distinctions are, which seems implausible if it's meant to be an account of how meanings evolve. And secondly, from a point of view of language acquisition, it seems as though, at least in some cases, what makes a prototype theory plausible is that a language teacher might actually use prototypes or exemplars as a way of ostensive definition. And that they're not necessarily emergent, but they're enabling.
Okay, about the first question. So, do I assume that you only get categorization because you have a fixed number of messages and less than the number of possible states? Yes, in the game, that's happened. Of course, there are other ways of trying to. I agree, right? This is unnatural because this is actually not what's happening in actual life. So you can try to do something about that, and one way that you can do something about that is to say, okay, you have maybe many messages, but sometimes messages get more complicated. So you have to, so you have many messages, but some categorizations might be more important than others, but also not only is your payoff depends on how similar what the receiver chooses is to the initial, the state speaker and hearer were in, but also by the cost of the message. And then if you have, well, you can play with that, right? And then the costs don't have to be maybe so much that it still has an effect. So the more important it is to make fine-grained distinctions, maybe that if you want to make fine-grained distinctions, you have a more costly message, for instance. And then you can make sense of this. So if things are not so important, then you use a shallow message, let's say a not so costly message. So you can. So the answer is, you can have maybe also infinitely many messages, but there's an additional thing to play with, and that is the cost of the message. And maybe that accounts for that. About the prototypes. So this is used for learning. Yeah, it is used for learning. But also in the game it's used for learning, right? Because in a sense both the speaker knows what message he's going to say because he heard what the hearer he has chosen, and the speaker also learns about, so both speaker and hearer, in a sense, update their mind, let's say, right? And they use the prototypes for that. So it plays an important role in learning as well.
So I want to follow on from Ewan's question, probing the role of signaling games in modeling human conversation. So signaling games are set up, as Ewan said, and as you acknowledge, as games where all the participants have common knowledge prior to acting about all possible options and all possible outcomes of those options. They might not know each other's preferences, and they'll have over those outcomes, and they'll have probability distributions over them. In a standard signaling game, one of the agents has privileged access to the actual state of the world that others lack. I have issues to take with all those assumptions. So I don't think it's true that in a conversation, a recipient of a message can, with any reliability, reason about why the speaker chose the signal he did in contrast to the other signals he considered, because with natural language, it's rich enough to have an unbounded number of signals. And I don't know whether you considered a particular option and chose not to say it, or whether you just didn't consider it at all. What the bounds of your game was as compared with, you know, what you actually considered the bounds of the game to be, the options to be. So that's one issue I have with it. The other is that we learn about the domain and about the possible states through information exchange in the conversation. And so my intrinsic preferences over those states may change as I converse with you. And finally, it's not true that a speaker, in the process of conversation, and I'm not talking about one-off games where one person speaks, the other reacts, and the game ends, but actually there's ongoing conversation, that only one speaker has access to the actual state. But in fact, language learning is embodied, as Ewan said, in a way that signaling games don't really model. So how would you address these issues with signaling games?
This is working, yeah. I agree with all your things, right? So first of all, about the first thing that you don't know, well, as I said to you already, right? This is an ideal model, right? So you have a particular set of messages. You have, whether you do it evolutionary, he was asking the evolutionary question. You ask more the rational question in actual conversation. In the game, you assume you have a limited set of messages, and you know you have, and it's common knowledge. Most of all, it's common knowledge. You have a limited set of what actions are possible, and it's common knowledge. And you have a limited set of, well, what are the typical states, and it's known what are the probabilities of the different players. Of course, that's all not true, right? And the idea is, look, these are the ideal circumstances. We want to overcome that. One way to overcome that of the limited set of messages is, well, maybe have more messages, but there are costs. That's more the evolutionary side. Your side is more, we don't know what alternative messages there are. If you want to, well, let's do, because we use this, I use this stuff also, and others have used this stuff, these conversational implicatures, to account for conversational implicatures, right? Yes. And then alternative messages play a big role there, as you know. Yes. Of course, right? In standard semantics, pragmatics, they are assuming that as well, and there it's equally, maybe equally problematic. Well, one of the ways is to see, okay, well, how can we extend the game that we actually don't assume that? And one of the so you can use actually signaling games with unawareness. People have worked on that to say, oh, we don't know, so that you say, oh, you might do that particular action, right? So what is the effect of a might statement? Well, one of the very natural ideas of to say, well, what is the effect of a might statement is, because if you analyze it in a standard semantic way, then it's just a consistency check, right? That's not complete nonsense, as you know, right? One particular idea about might statement is, so you might do that action. Oh shit, I haven't thought of that action. right? So you try to model that, for instance, in an awareness situation. So people are not aware about what type of actions are possible. And one of the effects of a communication is, oh, they enrich their awareness of the model. So, of course, game theory by itself doesn't allow that, because game theory only works if you have common knowledge, right? So you have to extend standard game theory. So just as I tried to say, okay, we have to extend game theory, we don't want to assume that people are perfectly rational, because that's not true. For instance, we want to use models of where people are bounded rational, right? And try to say, okay, how can we get equilibria if we assume that people are boundedly rational? Well, that's an extension of, and maybe we get better results there. So we just try to see how can we lose some of those, or get rid of some of those idealistic assumptions. Can we then better explain language use? Not so far away from what you're doing. And I completely agree, right? We also should be interested in, okay, preferences change during the time. I agree, right? Don't bother me with that yet, right? Because that's maybe just too difficult. But actually, you're working on that.